time in the sun without having to worry about all those things with a sleek and portable device. Now you can with UVSense, the ultraviolet detecting wearable sensor. In collaboration with the University of Utah Department of Dermatology, we've created a device that allows users to spend more time in the sun without having to worry about the consequences. Here's a video. Disclosure, we've been working on this project has been going on for 4 years now. But Eva and I and Alex are going to be going over the phase that we worked on this semester, phase 4. There are 3 engineerable components to our project: the iOS device, the circuit board, and the modular housing. The circuit board began being created during phase 3 using the Evo platform. However, this year we've expanded on it and included versatility, functionality, and complete accessibility. The circuit board has 3 main components to it. First, the UV sensor and processor, which takes data from the sun and transforms it into information we can understand. Then, using a Bluetooth transmitter, all of the sun data is sent to a user's phone. And then finally, our power supply. With one single lithium-ion coin battery, our device has a lifespan of 10,000 hours. This is the device, and we've kept adaptability in mind, as it can be used from negative 30 degrees Celsius to 80 degrees Celsius.
The creation of the housing module actually began during phase 3. During phase 3, the housing module was really simple. It was just a box that the circuit board would fit into. However, during this phase, we collaborated with Alex.
So for the past few months, I've been working on designing an improved housing module for the UV sensor. Our main goals for this module were for it to be efficient, portable, and versatile as possible. And in order to accomplish this, I designed it to be worn in 2 ways. The first is through the use of a hook on the top of the module, which can be clipped to a backpack, jacket, or other outdoor equipment. And the second is through a loop on the back that can be attached to an armband, a backpack strap, or any other surface.
So a large component of our product is the iOS application that users are going to use along with the physical UV sensor device, and this is completely unique to this phase. So we actually began by reverse engineering a simple app that detects nearby Bluetooth devices in order to gain a better knowledge on how Bluetooth low energy is implemented in devices. This is important because our physical UV sensor device and the application is going to connect together via Bluetooth low energy, which was created to make the power consumption more efficient by transferring smaller packets of data and lowering the bandwidth. So upon downloading the app, users are prompted to create their own unique profile by creating a username and password, which is stored in a database called Firebase, which uses CocoaPods, which is a dependency manager. So after that, a user is basically prompted to take a survey that will determine their Fitzpatrick skin type, and then from there, we are able to set unique UV exposure limits depending on that skin type. And from there, they are taken to the main page where they're able to see their current UV exposure level as well as other information. So this app was created using Xcode and the coding language Swift and is currently functional on all iOS devices.
So every day, more than 9,500 people are diagnosed with skin cancer.
This means that each year, more people are diagnosed with skin cancer than all other cancers combined. Because of the obvious use and the need for this kind of technology, we are intending on releasing this product to the world in August of 2020.
And with our product, we intend on reducing all of those numbers, hopefully, because it makes sense to prevent skin cancer. UVSense. Thank you.